So elimination is the most commonly used way for solving systems of equations, just because your equations are not always set up for graphing. If it's not a perfect ordered pair. If it's set up for substitution, one of the variables is already isolated. That's not always the case. So for elimination, usually your equations are in standard form, and you really just have to kind of figure out, well, which variable you want to eliminate. So depending on the equations, you may need to multiply one or both of the equations by a scalar value so that the same variable in each equation has an equal but opposite coefficient. And I know that sounds like backwards or hypocritical, but that would, opposite and same means same number, like 3 and 3. Opposite would be positive and negative. So you would want like 3x and negative 3x, or 8y and negative 8y. So equal but opposite. So determine which variable you want to eliminate. And then multiply one or both of your equations. So when you multiply and get this new equation or equations, you'll add the two equations you have, and if you multiplied or got your new equations correctly, one of your variables should eliminate. So when your first variable eliminates, you can solve for your first variable and just like substitution, then go and plug that back in. So plug in the variable you just solved for into one of your original equations. The hardest part here, again, is kind of the setup of making sure we're multiplying by the correct value. If we even need to multiply, what do we multiply it by? So just keep in your mind opposite but same. Want same number, positive and negative. But we're going to have to get an entirely new equation and alter the equation we have to do that.